Assalamualaikum and hi. In this video, I will show you how to do parameter estimation using model 2 ordinary differential equation that I solve using range kata order form method. The model of ordinary differential equation is dp over dt is equal to ln k times p. That is equation 3.5. For equation that I roughly estimate using decreasing rate, the value of k is 0.6687. So this is the formula of range kata order for pi plus 1 equal to pi plus 1 over 6 times k1 plus 2k2 plus 2k3 plus k4, where this is the value of k1, k2, k3 and k4. The initial population is p0 equal to 50, and this is the value of data that I get from my experiment. In order to find the value of the next iteration, pi plus 1, we need to know the value of pi, which is, in this case, we know p0 is 50. So first, let me put here p0 at iteration 0 is 50. And then for k1, we are using this formula equal to h, so I take here, times with FTI PI. So we know that our FTI PI is equivalent to dp over dt. dp over dt, that is ln 0.6687 times p here. Right. So we refer here FTI PI ln 0.6687 times p. Ln 0.6687 times p. P is our population. Okay, next we move to K2. Okay, so this is the formula of K2 equal to H times FTI plus H over 2 PI plus K1 over 2. So FTI plus H over 2 PI plus K1 over 2, I have substituted into the formula. So we have here ln 0.6687 times with, for P, PI, here we need to add K1 over 2 here for this term. Okay, so equal to H times ln 0.6687 times with PI, where PI is the population at iteration 0, PI plus K1. K1 is the value that we calculated just now, over 2. And then we enter. So we get here negative 16.020724. Then for K3. So for K3, H times FTI plus H over 2, PI plus K2 over 2. So here is for K3. So for the formula, ln 0.6687 times PI plus K2 over 2. We change P into PI plus K2 over 2 according to the formula. So equal to H times with ln 0.6687 times with PI, where PI is our P0, plus K2 that we calculate just now, over 2. Formula of K4 is H times FTI plus H, PI plus K3. So we change the formula here. So PI, we need to add K3. So ln 0.6687 times PI plus K3. So equal to H multiply with ln 0.6687. Okay, and then here times with PI, the value of P0, plus K3 that we calculate here. Okay, so for K4, we doesn't need over 2. We just need to add K3 here. So enter. Alright, so we already done K1, K2, K3 and K4. here we want to find P1. So our I is 0. So this is equal to P0 plus 1 over 6 times with our K1 here, just select this, plus 2 times K2 plus 2 times K3 here plus K4. Okay, let me check. So this is PI, T15 is our PI, plus 1 over 6 times K1 plus 2 K2 plus 2 K3 plus K4, and then enter. In order to get to the next iteration, if you want to find the value here, you need to know the value of K1, K2, K3, and K4. So you need to calculate one by one before you can solve the next iteration. By using Excel, you can just drag. So firstly, to do it, you drag first for the K1, K2, K3, K4 only, this one for this 4 only, and then drag here. Okay, this is because we do not put a dollar sign here. We put a dollar sign to lock the cell at E12. Here also for K2, K3, and K4. Okay, and then we select back K1, K2, and K3, K4. Then drag it back. So you already get the value of K1 or P1 at iteration 1. To get the value from P2 until P8, we can just drag, firstly highlight all of these and go to here. You can see the plus sign and drag until the 8th iteration. Alright, you already get the branch kata or the for method. Okay, so you can see here is the value that you get before the parameter estimation. So I want to calculate the error between the data and before the parameter estimation by using the formula of sum square error equal to data minus with before the parameter estimation power of 2 and then enter. Same goes to others, or you can just drag like this. And I want to calculate the total sum square error equal to sum, drag this, 1, enter. So you can see the total sum square error is 261.3784. So this is the data that we get from the before parameter estimation. The total sum square error is 261.3784 with the value of the parameters k is 0.6687. I have another table, same calculation as just now we calculate using the range kata order for method. Okay, so since I want to minimize the total sum square error by changing the value of k, so I'm using solver. Go to data tab and go to solver here in analyze group. Alright. Our set objective is our target cell. So my target here is to minimize the total sum square error. So I'm choosing the cell here, J38. And I want to minimize, click minimize by changing variable cell. Is the parameter that we want to estimate. So I'm select this cell and then click OK, soft. Then OK. So for this one, this is after the parameter estimation. So you can see here, the total sum square error before the parameter estimation is 261.378. And after we do the parameter estimation using solver, we get the total sum square error has decreased to 22.1141 by changing the parameter of k from 0.6687 that we roughly estimate using decreasing rate. It's changed to 0.5285. So I want to do the graph. Go to insert tab, go to chart, okay, and then select the data here. So I want to do data before and after parameter estimation. Add here. The series name is data. Series of x value here. And series of y value. This one. Then click OK. So this is the plot for my data experiment. And then we add again. Series name is series name before parameter estimation. X value, we choose the same. And y value before the parameter estimation. Okay, so the orange one is before the parameter estimation. Add again, after parameter estimation, click this series of x value and y value here. Then click OK. This one OK. Okay, we add some chart title and also legend. Okay, for this one, I want to change also the chart type, data, plot only, before and after parameter estimation. I'm using the smooth line. Then click OK. Chart title, we can change into parameter estimation. For model 2, using numerical method. Range kata order 4. The blue dot is my data that I get from my experiment. The grey one, this one, after parameter estimation. The orange one is before the parameter estimation. The grey line curve is the best fit for our data experiment. After using the solver rather than before parameter estimation. That's all. Thank you.